Colorado, and this is the stuff that I discovered using this Honeypot on my lab network. So among the other devices that are on my network, and I do a lot of IoT stuff. I run infected machines and allow them to beacon for an extended period of time. But I also have this Honeypot that's facing the DMZ of the network that I'm on. And it's basically a collection of most of the HoneyNet project honeypots that have been put into a single ISO and packaged up nicely in Docker containers by the team at Deutsche Telekom in Germany, and they call it the Teapot, like T-Mobile, right? So when you browse to the page that the Teapot is sort of hosting as its web front end, you get this weird like Charlotte and Emily Bronte text mixed in with some like techie terms and a login dialogue. And so this thing is just there to collect comment spam and people attempting to brute force log into a web page. If you do an nmap of the machine, it actually comes back, depending on which port it's scanning, it profiles it as a Linux server, a Windows box, a Windows server, a Konica Minolta printer, a bunch of different scanners. Like literally, like it's basically 15 machines in one, which is why I love using it. This box gets hit with an enormous amount of traffic. Now this is on a sort of consumer grade DSL line, DMZ port. This thing is getting hit with just unbelievable amounts of bad stuff. This is just everything that's on the outside of the firewall. So everything from brute forces to these like comment spammers, and just every service you can imagine is getting hit nonstop 24 hours a day. So the tools that I use in my lab are some of Symantec's tools that they acquired when they bought Blue Coat. And what I'm showing you here is screenshots from a thing called Security Analytics, which is a full speed, like, enterprise level network packet capture tool that has its own sort of SIM interface to it, so that you can observe and profile your network traffic, but then if you need to, you can drill down, right down to the packet level, and it stores the packets for an extended period of time. So looking at this traffic, and this is using the Honeypot as an endpoint in this filtering of all the network traffic. I started to notice this traffic hitting port 1433, and it started around the beginning of this year, and it has been steadily increasing until it's now the number 4, number 5 port that's being hit on the Honeypot every single day. And that kind of got me curious to sort of understand what the deal is with all of this stuff. If you look at like a 7-day period, and this is just one canonical example of 7 days of traffic to the Honeypot, it's pretty, spread out. The countries that you can imagine would be some of the largest ones: China, France, the United States. There's some that there's no geolocation for. Strangely enough, there was kind of a lot of traffic that particular week that came from Vietnam. But when you filter it down to just the traffic that's on that port, 1433, that 77% of it about was from China. So why is China so interested in this server? Looking at that traffic that just was the traffic from China, taking away that port and sorted by the application layer sort of DPI categorization of the traffic. There you can see here there's like SSH, there's HTTP, and then there's this thing, number 4, is called TDS. And now I'm not a database guy, but I discovered in the course of doing this investigation that TDS is a protocol that means tabular data stream, and it is essentially the protocol that is used to communicate with a Microsoft database server that is public facing, that's over the internet. I created a rule that basically triggered me with an alert every time there was one of these TDS connections to the Honeypot, and after a few weeks, there were 14,000 or so, alerts that flagged on this. By now, it numbers in the hundreds of thousands. Again, I'm getting about 2 to 30 of these per hour, most of them coming from network in China, and I really wanted to know what this stuff was. And as the Honeypot, it was doing a great job of collecting this, but I had to just pick out one bug and look at it, so that's what we're going to talk about. So the typical version of this attack runs from 2 to about 3.5 minutes. It's fewer than 500 packets in length. And the way that this protocol works is that there's an open connection. It does the SYN and the ACK, and then it opens the stream, and the stream stays open for the entirety of the attack, and then it closes. So it makes it very easy to kind of encapsulate an attack into a single package that you can look at. When you want to follow TCP stream, you literally see the entire attack from beginning to end. So some of the elements of the attack are these. Initially, the attackers are basically profiling the machine, and they are making some configuration changes. These are all automated, and they're very, very redundant and very repetitive. They'll try 5 or 6 different ways to do the same task, and they do it multiple times during the session. So out of those 500 packets that are being used, there's not very much unique stuff in there. But what it is doing is it's doing a lot of these database queries to set up these things called stored procedures and extended stored procedures. And all these they're essentially database queries that invoke DLLs running on a Windows database server to do certain functions. And it creates these sort of, large, agglomerations of these extended stored procedures, and then does database calls to call those features. And there's, the URL here is just sort of about how stored procedures work. All right. So like I said, when you follow a TCP stream, if you just do it in Wireshark, you can see basically the entire attack, and you can see that it's all SQL query commands like in plain English. So no decoding necessary. Like it's all just like letting it all out there. And there are 122 steps in this process. A typical example of this is on this paste bin. So if you go to that URL, I've taken one of these, just the strings from the TCP stream, and I've put it in the paste, and you can kind of follow along here. The server is great because all the server does whenever any of these commands come in is just say, okay, yeah, I'll do that. Give me more, give me more. And so the automation just works every single time to get them to send me this bad stuff. So in the beginning, it's taking control of all of these stored procedures. The first thing it does is it wants to configure the server the way that it knows how it's configured so that it can then do things and have the expected result later. So it drops a lot of these stored procedures, and then it basically re-adds them again. That's just in case if you're a clever DBA and you've not that clever because you've put your, database server facing the public internet, but if you're a clever DBA and you've kind of changed some of the default stored procedures so they do different things or so that they trigger you, this kind of cleans that up and makes it work the default way. They unregister and deregister a bunch of DLLs and executables that are part of the system. They delete IFEO keys. That's image something execution options, image file execution options, right? So there's a registry key path for every executable that's registered to run in Windows. And if the IFEO key is set, it's usually used for debuggers. So basically you could use it to hook your debugger instead of run the application. But if you set the IFEO key to basically do nothing, then you try to launch that application and nothing happens. And it's a kind of dumb way to, force your machine to not let it run PowerShell, for example. But so they delete all the IFEO keys for these executables. They remove group policy keys. They're changing the macro security settings on the database engine, which is called JET. And then they start to sort of take control by looking for registry keys that are commonly used by other malware, which I thought was kind of interesting. So think of this as sort of an automated capture the flag that's being done sort of in the real world. They're going out there and they're hitting these registry keys that have been known to be set by other malware groups, and they're unregistering the registry keys so that those malware can't run, right? They're basically taking over the box and defending it against other attackers. Then they create this service called SQL Server Agent, which in theory you're not going to notice if your database server is just running in a closet somewhere, and they start doing stuff like using regserve32 to query DLLs that are named strange things on the internet and try to register them on the box. It also tries to download other DLLs and other executables and other MSIs and install those as well. In my experience, by the way, in watching all of these attacks, the thing was able to get the database, the fake database server in the Honeypot to invoke these commands. But then when I went and tried to like pull those files down, or when the Honeypot tried to pull the files down, they weren't available. So this might just be automation that's just left and has been running haywire for a period of time, because the payloads are just not there right now, or they may come back at any time. So it's changing access control lists. So there's all these other things that are getting written in here, and you can see this is one of the stored procedures that it creates, and as part of that, it's sort of telling the page the server to download from this server and put this file in there and call it myusa.dvr. It's a batch file, and that batch file is doing a bunch of other bad stuff. Finally, again, it's looking for other malware that's on there. So it's looking for these program folders that, everybody who has Windows has a folder called Shangda, right? Or Kugu 2010. Like, everybody has those. Who doesn't use Kugu 2010? But this thing is going in there and it's deleting everything under those folders, right? And then we're basically at the halfway point. So looking at our IOC so far, we've got these 4 URLs that are part of the sort of initial attack and configuration thing, and some of these files and paths for batch files and other stuff. All right. Phase 2 is where they start to add the stored procedures in there and really start to do bad things. So initially, it had deleted and re-registered a bunch of the default stored procedures. Now it's going to go in and create these extended procedures. And one of the coolest things about these is that they're almost always encoded as just hex. And what they're doing is they embed these things that look like this into tables in the database, and then they use other stored procedures to say, go to like this part of this table in the database and do like an unhexing of it. And what you can see is something like this, which is decoding to something that's invoking ActiveX to do stuff like, scripting.filesystemObject, right? So like if you've done any kind of malware analysis in like the last year, and you've seen these like maldocs and stuff that are invoking all these internal services on Windows, then you're probably familiar with this, and it's basically using a lot of the same stuff that we see in weaponized docs. So I'm not going to walk you through all of these, but basically this is where it's doing a whole bunch of redundant stuff, where it's getting a payload, it's trying to install it in various ways. Sometimes it will pull the payload down and embed it in a table in the database, and then use an extended stored procedure to call that table, write to file, and then shell execute that. Other times it's just trying to directly pull the file from a remote server and either register it if it's a DLL, or run it if it's an executable or a batch file. It's using ADODB stream to do the downloading a lot of the time. And again, like, it's very redundant. So it will do all of that in one method, and then it will basically repeat all of the same things using a different method that's just slightly off, so that it makes sure that just in case you're running a different version of Microsoft SQL Server, that the commands work and it has accomplished its task. And then at the end, when it's kind of done with all of this stuff, it's basically encrypting the database. It wants to kind of clean up and make sure that you can't see what it has done. And it's pulling down more DLLs and more executables to the box to sort of accomplish that. Right? And then the last phase of this is after they have apparently like done whatever it is that they want to do, and they've got all the malware installed that they want to install, they're burning the database to the ground. And the way they do that is it creates a username called MSSQLA, which is one letter off from the default user account for MS SQL. And they give it this username, or this password, bus3456#queen, and then they run a script that then looks for a whole bunch of other accounts that might be on the box, and it uses this stored procedure called SP password to change it from a null password to a different password, including the account that they had just created. So that's the weirdest thing, is that like they create one account, they give it a password that's pretty strong, and then they just change it a second time. To me, it just smacks of, it's an automated script, it's just running at speed. So after I got all of this data, I wanted to do some cross-referencing of it with the data sources that we have within Symantec that let us know the reputation of IP addresses and domains and files. And we call the tool that does this Billiard Room. And the way that it works is it takes input in the form of those 4 types of data, file hashes, IPs, domain names, and the whois registration email. And it allows you to kind of connect the dots. Actually, it connects the dots for itself, and does all of this connection and tells you a lot about the relationships between all of these things. So this was my final list of IOCs that I used, that I plugged into Billiard Room, and what comes out of it is this crazy looking map that looks like this. Now, the stuff that I have circled in red were my starting points, right? So this one down here is one of the IPs that was being used to host some of this stuff. And the red icons that we have a little biohazard symbol are malicious files. And where you see a line with an arrow pointing to something or from something at one of these things, it indicates a direction of communication. If it's pointing from the little biohazard symbol to an IP or a domain, it means this sample was talking to this place. Likewise, if you see like these ones where the file was coming from a bunch of different places, it means that those hosts were hosting the file and were serving the file. So one of the cool behaviors that I noticed when I dug into the Billiard Room traffic was that one of the samples, which was this one, that was being pulled down as an executable, was running, and when it ran, it connected to a website in China that's pretty popular that's called Sina, which is it's basically like a personal blog site. So I wanted to go back into security analytics and see what the traffic to Sina looked like, and it turns out that on this page on Sina that it was querying, there was one post, and it was this base 64, which was an instruction for the bot. So I thought that was really cool, that they were basically using hiding in plain sight on a public blog for their command and control for this piece of malware. The other thing that was basically very telling about this is that here's our sig2016.xyz domain. The stuff that was co-hosted on this one of the IPs that was hosting it is a big portion of one of the Mirai botnets groups. So the malware that we're looking at here was it was explicitly Windows-based executables and DLLs and batch files and PowerShell scripts. But it was hosted in infrastructure that we have seen used extensively over a long period of time by Mirai, by at least one of the Mirai botnet groups, to host their stuff and do command and control. So it stands to reason that this group of people who runs this collection of servers is probably connected to the Mirai botnet in one way or another. Either they're one of the groups that's running it, or they're the service provider that's doing it, or they've just discovered different things that they can do, and they're experimenting with using the existing botnet to kind of spread their stuff. One of the domains that kind of popped out and was noticeable to me was this one, mypings.top. And so when I kind of looked at that also sort of pointed me into another universe of Mirai botnet traffic that we had known historically was bad. But then, basically, at that point, the trail goes cold because a lot of the samples were either unavailable or they weren't responding to the user agent string, or there was some server-side component that was basically preventing me from retrieving a lot of the payloads. So, fortunately, what's good about Billiard Room is that it collects data from huge numbers of sources. So all these other red file indicator things that are in here, we can pull the hashes out of those and then go into VirusTotal and pull them out of VirusTotal or pull them out of our own malware repository. And we were finding that, in fact, like a bunch of these other samples that were not Windows samples were things that were, targeting MIPS or ARM processors. And so they were less well detected by Symantec products, but we had seen them observe their behavior in the wild. And really, like, what ended up happening was that there were almost just too many rabbit holes to go down and chase these guys down. So I would definitely recommend my sort of high-end sort of overview of this is If you run a large network, whether it's a university or corporation, or even if you're just doing this at home, honeypots are the way to go, and you need to be collecting that data to be able to understand what are the threats on the other side of your firewall, and like where are the weaknesses in your firewall that they're going to try to penetrate. Do not be opening, holes for the database server thinking that that is a safe way to go. Contextually, like understanding some of this stuff, there were a lot of these IP addresses and domains that had been, that the Mirai botnet was talking to, and when we tried to look into those more, we discovered that they were honeypots, or sinkholes that were run by other security companies. And so, we don't want to classify a sinkhole as a bad IP. So, we had to kind of throw that data away. There's nothing wrong with sinkholing data, but it does, conflate the security company that's sinkholing the data with the attackers. So it's good if you work for a security company and you sinkhole domains that are used for malicious purposes, like please let everyone else know that this is your sinkhole, and if you see traffic to this IP address, it doesn't mean that, antivirus company Y is infected with something. There's also the problem of some of these domains, they get moved from host to host, and they might get parked for a period of time at like GoDaddy on a parking page with 62,000 other domains, and then they'll get moved to another IP for a few days and then put back on the parking page. Knowing the sort of historical context of where these things are hosted is pretty important. So I don't profess to be an expert in SQL. If I have made any mistakes during this talk, I welcome corrections and comments. And I think do we have a minute for questions? I know I was running late, but I'll just open it up for questions. And there's none. So someone needs to be brave. Yes, you, sir. So the question is, when we have a list of domains that are known to be malicious, what do we do to sort of keep track of those? So internally within, the division of Symantec that I work in used to be Blue Coat. And Blue Coat, if you know of them, they make proxies. And among the features of the proxies, you have this ability to basically classify categories of websites that you can allow or disallow your users to visit. And so a big portion of what we do is spend time categorizing IP addresses and domain names based on characteristics of this type of attack traffic into those good or bad buckets. That's how we monitor that stuff. And essentially what I've been doing since I started doing the analysis on this project earlier in the year is that I've just been collecting this data with security analytics, periodically watching to see if it changes. It never has. And it's always pulling from the same domains. And those domains essentially, they do change their IP addresses from time to time, but not very often. When they do, we have alerts set up internally that flag us to let us know when something big is happening, like, hey, all of a sudden it's turned on. And it might only be on for 12 hours, then it goes away. So hopefully that answers that question. All right. So I'm Threat Research on Twitter if you want to follow me, and I really am grateful to the con for inviting me and letting me talk to this